Hey everyone, let's take a minute here, look at some of our homework questions from week 8. I just hope you didn't see all the answers as I cruise back up to the top. Um, let's just look at a couple of these. I just make sure we're getting on the right track. Question 6 is asking 3/4 inch class 160 PVC IPS plastic pipe with a flow rate of 5 gallons a minute, has a velocity of blank feet per second and a PSI loss of blank per 100 feet of pipe. All right, now to answer this question, we need our charts. And if you've got the textbook, it's Appendix B. And these Class 160 are right at the start of Appendix B. If you don't have the textbook, I'm going to send you out a link for these charts. So we need to remember those things: 3/4 inch and a flow rate of 5 gallons a minute. So let's come to our chart, and we're going to remember 5 gallons a minute. So on the left side here, this is our gallons a minute. So we're going to find 5 and then come across here to this section is for 3/4 inch pipe, and that's going to tell us, all right, where our velocity is going to be 2.46 feet per second, and we're going to lose 1.33 psi. Now, one thing to keep in mind, this is really important actually. So this is talking per 100 feet of pipe, and that's going to play a big role on as we get into different questions and more complicated questions. But for that one, those are the numbers we're looking for. So good way to get started with this. Next question, we're just looking at a different size of pipe, so you can do that. Question 8, we're looking at 18 gallons a minute flowing through 1 inch class 160 PVC pipe. And it's stating that that's within an acceptable range. Let's go find out if it is in an acceptable range. So we're going to come over here. Again, we're looking at 18 gallons a minute. Come down the left side. And then let's work our way right into this column, which is for the 1 inch size pipe. Okay, we're in the gray here. The gray in this case is bad. We don't want to be in the gray. The reason we're in the gray is because we're 5.32 feet per second. And what's our number we want to stay under? 5. We don't want to ever exceed 5 feet per second. So would that be acceptable? No. Get into question 9. Question 9, I want to take a second on because there's two ways to do it, and they're both acceptable ways, and that's what the point I want to get across. So, the velocity of water flowing through a 1.5 inch pipe at 2 gallons a minute. So now, the initial thing I would do is go back to that chart. All right. So 2 gallons a minute, and let's come over here into the 1.5 inch pipe. So we have a velocity of 0.27 feet per second. Come look at the answers. Okay, none of them are close to 0.27 feet per second. But now I'm thinking, like, wow, that was really easy. Maybe I actually should do some calculations or something. So, in the textbook on page 165 is the calculation for velocity. So it is V equals 0.408. That's just a constant. Just plug the same number in there. Times by Q, which is our gallons a minute, and divide all that by the inside diameter of the pipe squared. So it looks like that. So let's plug our numbers in. 0.408 times by Q. We know our Q, it's 2, and that's going to be divided by the inside diameter of the pipe. For that info, we just come right back here to this chart. And up here, we have our average inside diameter, which is 1.734 inches, and we're going to square that. We plug all that into the calculator. And we get 0.271388, goes on and on, but so 0.27. So just wanted to show you that it is acceptable to use these friction loss charts. These friction loss charts are very helpful, and save us a little bit of that math. All right, let's keep her moving. So, it doesn't look like we have a correct answer there. Water meter question. Well, there's got to be a chart for that, and you do need the textbook. That's in Appendix B. So if you don't have the textbook, find a friend who does. Um, and it's just, again, a lot of just kind of reading, understanding these charts will save us a lot of time and effort with calculations. Let's see. Question 11, the pressure at the source is 40 psi. You must have at least 10 gallons a minute and 20 psi at the end of 500 feet of pipe. What is the minimum diameter PVC pipe you should use? Okay, so we're going to be using that friction loss chart, but first let's just look at this question. Let's just flush it out here for a sec. So at the source, we're 40 psi. At the end of our pipe, for whatever we're doing there, we only need 20 psi. So we've got some leeway there. We can lose 20 psi along that whole length of pipe. That's acceptable in this situation. Okay, and we know we got 500 feet of pipe. So if we think about our friction loss charts, that's all done in 100-foot lengths. So I like to just make her all real simple and put it into that same metric. So let's do 500 feet of pipe and divide that by 100, and we'll just say we got 5 lengths. So what we know is that over those 5 lengths, we can lose 20 psi. So if we go 20 psi divided by 5 lengths, then we can think, okay, we can lose about 4 psi per length. Now let's go to the chart and see if we can find a pipe that we meets those parameters. So we want to flow 10 gallons a minute, and we want to make sure that our friction loss is less than 4 psi per 100 feet. So let's come here, and again, we'll start finding out our gallons per minute. So we'll go here at 10 and start working our way across. So 3/4 inch pipe, our PSI loss is 4.79. Well, that's going to be a little too much. It's above 4. So 3/4 inch pipe, that's out. Let's move over to 1 inch pipe. PSI loss on that is 1.38 PSI, and that's per 100 feet. We already figured out that 4 PSI loss is acceptable, so let's go with it. So 1 inch pipe. Hey, look at that, correct answer. A lot of these, we're just going to be doing the similar thing. You get into 12, 13, 14, maybe 15 too. It's asking these questions about a golf course. Schedule 80 pipe, so we're going to be looking at a different chart. We can look at these. A lot of them, like I say, are going to be pretty similar. Let's look at 13. That's a little trickier though. So the owner wants to irrigate a golf course 1 mile away, 100 feet ahead. PVC Schedule 80 IPS plastic pipe will be used for water conveyance. Do not exceed 5 feet per second. What size pipe would be needed if your system required at least 40 psi? All right, so first thing I'd do with these questions, and so on question 12, I would do this and get this info. We'll do it here for 13 because it'll work just the same. So we know that wherever our pipe's going here on the golf course, we need 40 psi there. Clear back a mile to our source, we have 100 feet ahead. So right away, I would just convert that 100 feet ahead into PSI, just so we're talking apples to apples here. So 100 feet ahead, to make that into PSI, we know that it's 2.31 feet per PSI. So we can divide 100 by 2.31, or we can multiply it 100 by 0.433. Either way works. But so by doing that, we figure out, okay, right there at the source, we've got 43.3 PSI. 1 mile away on this golf course, we want to have 40 PSI still in the pipe. So basically, we're willing to only give up about 3.3 PSI over that 1 mile of pipe. All right, so that's important. So let's think about that, 3.3 PSI. Next thing let's think about is 1 mile. So you convert that into feet, that's 5,280 feet. Let's put it into lengths because we're going to look at that chart and do some calculations. So 5,280 feet, let's divide that by 100. That's going to tell us we have 52.8 lengths. All right, so we got a few things to remember. Let me write these down for us. So we got 52.8 lengths. We're willing to lose 3.3 psi, and so let's first deal with those. So let's divide up that psi loss, so just we can really figure out how much we can lose per length. So if I go 52.8 lengths and divide that by our 3.3, okay, sorry, I did that backwards. Go 3.3 psi and divide that by 52.8. And that's going to tell us that per length of pipe we're willing to lose 0.0625 psi. That's our limit. That's our maximum loss per 100 feet. All right, perfect, good to know. And what else do we need to know? Okay, 50 gallons a minute. All right, let's take this info here and let's go and look at our friction loss chart. So let's start down here. Oh, first of all, we're on Schedule 80 pipe, so let's make sure we're on the Schedule 80 chart. A lot of different kinds of pipe. Schedule 40. So Schedule 80, it's a thicker wall pipe than a Schedule 40. For any curious. All right, so we found our chart, Schedule 80 PVC IPS plastic pipe. Let's find our 50 gallons a minute, and let's start working our way across. Remember, we want our max level of psi loss per 100 feet is 0.0625. So here we're like way high, almost 9. Getting into 2.5 inch pipe, we're still over 1 psi. 3, still too high. 4, 0.09, getting closer, but we're still too high. 6 inch pipe, 0.01. We found a size pipe that's under 0.0625 psi of loss per 100. So that'd be a good pipe to choose. Once you got that figured out, you're on your way. You're doing really good with all this. Question 14 gets into let's add a valve and let's add an elbow in it. So for that, you're going to want to look in the textbook at page 172. That's where we start talking about calculating losses and valves and fittings. It's similar formula to that. It does have a coefficient though, so you need to use a chart on page 174. I don't have an electronic version of the textbook, so it's hard to show you this part, but give this a try. So 172, that's where you're going to find the formula you're going to need for losses and valves and fittings. I'm also adding it in a PowerPoint that I'm going to send out, and then there's a table of coefficients on page 174. It's really just plug numbers into those formulas and you'll figure out your losses. So hope this has been helpful. It's tough, guys. Water hydraulics is confusing stuff. If you're having problems, get a hold of me. Hope you're doing good and liking the class. Take care, everyone.